On all the brief forays into space so far, astronauts have sustained themselves almost entirely on packaged food. But if humans ever hope to set up long-term habitats on the Moon or Mars, their physical and mental health would benefit from the ability to grow plants. Welcome back to our channel Technology Talk, and today, we're going to discuss farming on Mars and Moon. Space agencies from various countries have spent decades developing the technologies necessary to bring farming indoors. And now the German Space Agency and NASA are pushing the state-of-the-art of soil-free gardening to its limits with a greenhouse in Antarctica and laying the groundwork for their next act: farming systems where the farmers are optional. NASA has worked to advance space agriculture, in part because a robust plant collection could serve as the ultimate multipurpose life support system, producing calories and nutrients to eat, making oxygen to breathe, and taking carbon dioxide from the air. Building on Soviet research, NASA funded a variety of agricultural programs in the 1980s and 1990s. In a collaboration with the University of Wisconsin, researchers discovered that they could replace hot and cumbersome incandescent grow lights with a particular blend of LED lights. Red LEDs, which were more energy efficient, let plants photosynthesize. But plants also needed blue light, or they would grow too tall and spindly. The work led to a patent, and today's indoor farms often feed plants on a similar diet of red and blue photons, which is why indoor farms often appear bathed in purple light. Focusing on ways to sustainably meet the ever-growing demand for food, companies around indoor vertical farming have seen a boom in recent years. New York-based startup Bowery Farming announced a $300 million funding round in June, the largest in the industry thus far, valuing the company at $2.3 billion. Kimball Musk, brother of Elon Musk, is the co-founder of Square Roots. Newark-based Arrow Farms in April broke ground on a 136,000 square foot farm in Virginia, set to open in 2022, that it says will be the largest aeroponic indoor vertical farm in the world. The Eden ISS Antarctic Greenhouse, now entering its fourth growing season, continues to prove that you do not need fertile ground or even sunlight to produce vegetables. It builds upon the LED blend pioneered by the early NASA experiments to deliver recipes, tuned to the needs of each specific vegetable with programmable arrays of red and blue lights. Roots poke through beds of fibrous minerals and dangle into empty trays below, where automated nozzles spray them with a nutrient-rich mist every few seconds. Water is largely recycled, except when the nutrient solution gets depleted and needs to be dumped and replaced every few months. The entire system plugs into the neighboring German Neumayer 3 research station, from which it continuously draws about 10 kilowatts of power, comparable to 8 U.S. households. The first year, a DLR researcher named Paul Zabel ran the 135-square-foot greenhouse and collected nearly 600 pounds of veggies, including cucumbers, lettuces, other leafy greens, tomatoes, radishes, and herbs. Having an AI system taking care of the greenhouse is preferred, according to Daniel Schubert, the project coordinator of the Antarctica experiment, in the case that the astronauts just have no time. This year, NASA has sent one of their own researchers, Jess Bunchek, to test out the U.S. Space Agency's preferred strains of space veggies in Eden ISS. Another major research goal will be to collect detailed data of what tasks take up the most time. Bunchek will carry an 8-sided programmable timer that she will use to track the hours she spends on 8 categories of work. Next in the pipeline, DLR is currently designing a new facility, a semi-inflatable, space-rated cylinder with a few new tricks. One improvement will be advanced remote monitoring. Annalisa Paul and her colleagues at the UF Space Plants Lab are developing software that can take GoPro images and recognize how a plant's appearance changes with stress. When a plant needs water or has been exposed to too much salt, the colors of light it absorbs and reflects shift subtly in ways imperceptible to the human eye. But the lab system can spot salt stress in just 15 minutes and drought stress in about an hour, according to Natasha Singh, a researcher at the Space Plants Lab, much earlier than a human can. Soon, the researchers plan to introduce intentional malfunctions and see if the lab system can catch them. Such a facility could touch down on the Moon or Mars ahead of astronauts and have a basket of cucumbers and tomatoes ready for their arrival. Astronauts would have the option of gardening, which can bolster mental health, but the crops should be able to thrive on their own when astronauts have more pressing tasks. And with that being said, it's time to end our video. What do you think about farming on Mars and Moon? Let us know in the comments. Like this video and subscribe to the channel for more amazing videos like this. We'll see you in the next video.